Hello, let's continue our Sudoku adventure with Release the Spots by Sanabas. Now, normal 6x6 Sudoku rules do not apply. Some Doku rules apply, so let's go over this carefully. We are placing the digits 1 to 6 in the grid, so every single cell is still limited to 1 to 6. Digits may, and indeed must, repeat in some rows and columns. Rows are numbered from top to bottom. Columns are numbered from left to right, so row 1, row 2, row 3, column 1, column 2, column 3, etc. For each row or column n, it contains n distinct digits, i.e. column 1 is at the far left and every cell has the same digit. So maybe they're all 2s or all 3s or all 4s, for example. Row 6 is at the bottom and contains 6 different digits. So this needs 1 to 6 once each. So we could do 2, 3, 4, 5, 6, and that would, of course, make all these ones. All right, so that would be one way to do that. We also have crop key, the black dots in the grid. Digits separated by a black dot have a 1 to 2 ratio, meaning one is exactly double the other. So if this was a 2, this could be 4, because 4 is exactly double 2, or it could be 1, because 2 is exactly double 1. Not all dots are necessarily given. So if we have a 2, 4 here, we could have had a black dot there. We don't. That's perfectly fine. We're allowed to do 2, 4. Then we have a German whisper line here. Adjacent digits along the line have to have a difference of at least 3. So if this was 2, this could be 5 or 6. 5 has a difference of 3, 6 has a difference of 4. Those are our only two options, though. If we tried to do, say, a 4, that has a difference of 2, that's no good. If we tried to do a 2, that has a difference of 0, that's still no good. Has to be at least 3. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right. So German whispers are still going to follow our normal German whisper rule that we're all familiar with if you've done it before, which is that it's going to alternate low, high, low, high, low, high. Probably the easiest explanation is if this cell were low, a 1, 2, or 3, then we need a difference of at least 3 from 1, 2, 3. So we can't stay in the 1, 2, 3 range. None of these numbers will have a difference of 3 with any of these numbers. So we're going to have to move up to the 4, 5, 6 range. And then once we're in 4, 5, 6, can't stay in 4, 5, 6. We've got to move down to 1, 2, 3. So we don't know if this is low or high, but we do know it alternates. So I'm just going to color it with alternating colors so that we can see how they alternate. All right. Now, there's something interesting, which is that row 2 has exactly 2 distinct digits. So that's the low and the high. That's all we get. Whatever the low is and whatever the high is, we're going to keep flipping back and forth between them. So I wonder, it may or may not be worth it, but I'm going to mark this with A. We'll do it in big note. A, B, A, B, A. Right? We don't know what A and B are. We know they're at least 3 different from each other, and we know we're just bouncing back and forth between them along this line. And so this is an A or a B. We don't know which one, but it has to be, it has to be an A or a B. Okay, what else can we tell here? This column here has 2 distinct digits. This is the other one. Well, I don't know if the other one's the right way to put it, but these 2 are distinct. So we have to be made up of these 2 possibilities. By the way, we have A's here, so all of these are A, if that's helpful. And then the top row is also all A's. So that makes this a B, because the 6th column has to have all distinct digits, has to have all of our digits. All right, so we know B is a purple color. Now in this column, we have all distinct digits. So we're going to have all 3 highs and all 3 lows. So we already have all 3 of our purples. We need 2 more greens. And in fact, we did know that A was green, so we can just green all of that. This column has 3 distinct digits in it. This column has 2. So this column is made up of A's and B's as well. Which means we know that these are B's. And then these are A's or B's. So this has to be A. It's green. And we've learned something about A and B, which is that one is double the other. So the high is exactly double the low, which means that B is even and is a 2, 4, or 6, I suppose, any even. Now this cannot be A. We can't repeat A, and so this has to be our purple B here. Now this row needs 3 distinct digits. This is distinct from A and B. So I wonder if it's worthwhile labeling these with You know, it might be actually helpful to say green is A, B, C, and then purple, which is our other low high. So like if A was low, it would be 1, 2, 3, right? Or sorry, 1, 2, or 3. And if B was high, it would be 4, 5, or 6, right? So what I'm thinking is instead of B, I'm thinking using A, B, and C for the greens and D, E, and F for the purples. So we're just going to call all these D instead of B. And so we're going to mark this E and this F, and then we're going to mark this B and this C to see if that helps at all. Now down here, we know that this is not D, so this is an E or an F. But I wonder if this black dot ratio is enough for us to get digits for A and D. They have to be at least 3 different, and also be exactly 1 to 2 ratio. So our options are 1, 2, 2, 4, or 3, 6. So I think it's pretty clear that 3, 6 is the only way to go because the other ones have too small of a difference. So we know that A is either a 3 or a 6, and D is the other one. And so, okay. And we know that this is D and this is E. So what would happen if this was a 3? If A was a 3, then both of these would have to be 6, but we know they're different digits, so that's not possible. So actually, A is going to be the 6. So we actually can just call A 6, and that means D is 3. So we have numbers for those now. We don't need to call them letters anymore. And so now we know that B and C are from 4, 5. So I think what I'm going to do is I'm going to change these to corner marks. Or actually, you know what? We may not need that anymore. Let's just put numbers in here now. We may be going a little overboard with our... sorry, I know this is 1, 2 because of this row. We need all distinct digits, but I don't know that this isn't 3. It could actually repeat the 3. Exactly one digit repeats in this row, which is kind of interesting. Now we need the last purple here. So this is definitely 4, 5, and this is definitely 1, 2. Now, can we use this German whisper? Yeah. So in column 6, we can't repeat a digit. So if this was 4, this would have to be 1 and 1, and that breaks this column. We can't repeat digits in that column. So it has to be 5, and that's 4, and that's 5. Now 5 can be surrounded by a 1 or a 2, so that's okay. We already repeated the 6 in this column. That's the only digit that's allowed to repeat. The rest of them actually have to be distinct digits. So this can't be 5. It can't be 5 or 6. 6 can only repeat once. Right? If you think about it, we got one digit that repeats exactly once, and the rest are unique in order to have 5 distinct digits. So it's not going to be 5 or 6, and so it has to be 4, which means it's surrounded by 1s, just from German whisper rules. So that's a 2. Now in this row, we're going to have to repeat something. This could be a 4 or a 6. This could, actually, this is next to a 3, so it has to be a 6. So the 6 is what repeats. So the 1 does not, so that's 2, and that's 1. Okay. Working this out as we go. Column 3 has 3 distinct digits. So we could actually repeat the 6 one more time. Oh yeah, we actually have to. That's another 6, because of the 3 here. And so I probably could have done more of the German whisper earlier. I hadn't really been thinking about it. This is just a digit that isn't 2 or 6 in order to have 3 distinct digits. This middle part's a little tricky, I think. Here we need 3 distinct digits. How about here? Here we need, yeah, right. We already have all of our greens. And the 6 is repeating, and we're only allowed to repeat once in column 5. So these actually are both purple. They're both low. The only 2 lows that can go across a black dot is a 1, 2 pair. Otherwise, we'd end up with 2, 4. 4 is not low, or 3, 6. 6 is not low. So now this row, we need 3 distinct digits. Well, next to a 1, 2, we can double the 1 to 2, or we can double the 2 to 4, or we can have the 2 to 1. What about here? What about this column? Oh, we have 4 6s in this column. So this is distinct from 6 and 2. So let's think about this. It's definitely not 2 or 6. You can never put a 5 on a black dot because you can't have it to 2.5. You can't double it to 10. So 1 would have to go with a 2. 3 would have to go with 6. And then 4 could go with 2. 4 has to go with 2, sorry. I was thinking about 8, but no. How do we resolve all this? We got to think about the distinct digits. Where is it going to be helpful? Maybe this row, 4 distinct digits. We have 1, 2, 3. We're going to need some repeats here. Okay, so 3, 6 would make a whole lot of sense here. So repeat the 3 and the 6, and that would give us the distinctest we need. Something like 1, 2 is a problem. We can't introduce 2 more digits. That's the point. We have 3 distinct digits. We can only use 3, 5, 6, and then 1 more digit. So 1, 2 would introduce 2 more digits. So we're not doing that. So that's not a 1. 2, 4 would also introduce 2 more digits. So we're not doing that. So we are going to be 3, 6, which makes a whole lot of sense. All right. That's purple. And then this column, we need 4 distinct digits. We have 3 distinct digits. So this cannot be any of the, this can't be 1, 3, or 6. We only have 3 distinct digits. So it's not a 1. What about this row? 3 distinct digits. So we can't introduce 2 more. So we can't do a 2, 4 pair because that would be 4 distinct digits in row 3. So if we're not 2, 4, this isn't a 4. So that's 2, which makes that 1, which makes that 2. And we're done. Let's just purple that. Cool. Really interesting puzzle, Sanabas. I enjoyed that. Not really a Sudoku, but a Sudoku adjacent enough, and it's using constraints we're familiar with. So that was neat. Every once in a while, it's nice to throw in a little curveball like that. Nice. Well, that solved very nicely. I think I could have made some deductions a little earlier if I'd paid a little bit more attention to what we were putting on this German Whisper line, but at the same time, it did flow very nicely, and I never really felt like I was super stuck. So very nice puzzle. I enjoyed that. Hope you did as well. And if you did, then why not leave a like, subscribe, and a kind comment below.